Example on two-way ANOVA, and you're going to see a lot of similarities between a two-way ANOVA and a one-way ANOVA. You kind of think of a two-way ANOVA as being one-way ANOVAs on steroids. So the example that I want to use here comes from a data set called BMI over hospital and gender. Now let's think about what do we need to run a two-way ANOVA. We need a quantitative variable, which in this case we have for BMI. This is our dependent variable. We need two categorical variables. These are our independent variables. This is our independent variable, what is called independent variable 1, and independent variable 2. So I have three variables, one dependent, quantitative, and two independent variables that are categorical. Two-way ANOVA actually has three null hypotheses and alternative hypotheses, three pairs. So the null hypothesis for the main effect of facility would be that the mean BMIs are equal across facility. The alternative hypothesis would be that mean BMIs are not equal across facility. The alternative hypothesis for the second main effect of gender is that the mean BMIs are equal across gender. The alternative hypothesis, obviously, would be that the mean BMIs are not equal across gender. And the the null hypothesis for the interaction is that the mean BMIs are equal across facility, cross gender, or the interaction between facility and gender. And the alternative hypothesis would be that the mean BMIs are not equal across the interaction of facility and gender. We will test at 0.05 as we've done consistently through this class. So the first thing I want to do is I want to test my assumptions, and to be able to test assumptions for a two-way ANOVA, we first have to create our model. But before we get into that, I'm going to just punch around a little bit and get to know. It's the geekiest thing I think I've ever said, but well, it's actually not. But get to know the data set a little better. So as we know by now, the first thing we have to do when we perform an analysis with categorical variables is force it to be a factor. R is I've found to be inconsistent with this, again depending on the analysis that we're running. The next thing I'd probably want to do is I'd probably just want to look at a table of facility, and I can see that I have 146 patients that were selected from facility A, 68 from B, and 119 from C. I would also like to get an idea of the gender distribution. It's almost equal, 168 males, 165 females. Probably want to look at some means. I would probably just use t-apply to look at the mean BMI over facility. And the means appear to be quite different. The BMI for, that's interesting, facility C seems to be quite a bit higher than for A and B. I'd probably want to repeat this for sex. And I can see that the mean BMI for males for this sample data is higher than for females. So going to dive into testing assumptions. It's kind of strange, but to test assumptions, we have to create our model first. So to create my model, just going to call a model. I'm going to use the AOV command, and I put my dependent variable first over the independent variable times the I'll call that sex, right? Yeah, the second dependent variable or independent variable. Now, if I just wanted to look at the main effects only, which I'll do this later, I just put a plus there, but I don't. I always want to start out at a two-way ANOVA, creating the interaction effect, because that's where my tunnel vision is. After my running the model initially. So I have my model, and now I'm going to dive into testing the assumptions. And so equal variances, we've been very consistent in equal variances. using Levine's test. So I'm going to do that, but as you should know by now, to run Levine's, you have to install the package library, and if you've already installed the package, install the package car, and if you've already installed the package car, then you just access the library. So I want to run Levine test, and I can just run it over my model, which is kind of cool. So, you know, some people claim that we should run the Levine test as the center being the mean. I usually do that, but there's actually pretty strong arguments that you should use the median. But I run typically report for the center being the mean. So remember, for Levine's test, the null hypothesis is that we have equal variances. The alternative hypothesis is we do not have equal variances. Our p-value using the mean is 0.1974, above 0.05, so we fail to reject the null and assume equal variances. The next thing we'll transition to is normality. And for normality, we're going to use the Shapiro test, but we're going to use it a little differently than we've seen before. We created our model previously, right up here. We created something called a residual. We created a lot of things, but we also created something called a residual. Residual is just a difference between what we observed and what we expect under the model. But the important thing is that we can use the model residuals, which we can get by typing this, just model. Again, the model goes there because that's what I call my model up here. And the residuals go after the $sign because that's the command in R to access the residuals for the model that we created using the AOV command. So what we're doing here is we are testing normality. See if I can type here. Yeah, the normality assumption. So we run Shapiro test, and our p-value is greater than 0.05. Again, remember, normality is well, actually the residuals are normally distributed. The alternative hypothesis would be that the residuals are not normally distributed. So we fail to reject the null, so we can assume that the normality assumption is met. Now, to test the outliers, what I'd want to do is I would look at box plots of BMI over facility and over gender. So let's just see what happens there. So I can take a box plot of BMI over sex, and I have no outliers, so good. All right, and box plot BMI over facility. I do have an outlier in, actually two outliers in facility B, and I'd have a decision to make. Would I want to delete those two outliers, or just go ahead and note to the reader that I've violated the outlier assumption? We have a couple of them in a sample size of, I don't know what our sample size is. Let's grab it. Just do whatever. So a sample size of 333 subjects. I wouldn't be that concerned with two outliers for BMI in one of the facilities. So I would proceed using the full data set. All right.